Hello, I am Professor N.B. Hulle from G.H. Raisoni Institute of Engineering and Technology. In this video, we will try to understand how to use the star and delta conversion, this kind of the circuit, and to calculate the current supplied by the battery in this case. This problem can be solved by the number of ways that we can use the mesh analysis. Here this will be the mesh 1, mesh 2, mesh 3 and so on. But here I want to use the technique that is star and delta conversions, means finding the equivalent resistance between the terminals and then calculation of the total resistance and then calculation of the current. For that purpose here I will mark this terminal as A, this point as B, this point as a C, and here this particular point as a D. And then we will arrange in a particular way. For that purpose, here I will mark the 2 points in the figure. This is the point A and this will be the point D. Here this is the point C, and finally maybe B. This is B, and here this is the final point, which is the C. And then we will connect the respective element between the respective terminals. But here condition is that in such case of the arrangement, the point A and D must be diagonally opposite, and which should be the horizontally. We should not take like this A, B, C and D, that kind of the way, because the end points must be diagonally opposite. That is the condition which will make the circuit simplified, otherwise circuit becomes complicated. Now here I will put the respective resistance between the respective elements. Now between A and B we have the 10 ohm. Here between A and B we have the 10 ohm. Then between B and C we have another 10 ohm. This is B, this is C, we have another 10 ohm resistance. It will be something like this. Then between C and D we have another 10 ohm resistance. C and D we have another 10 ohm resistance, something like this. Then look at here. Between A and C we have this 10 ohm resistance. A and C. Here is A, here is C. This resistance is again of the 10 ohm. 10 ohm. Each resistance is of the 10 ohm. Then finally between B and D another 10 ohm resistance is there. B and D we have another 10 ohm resistance, something like this. Now here I will connect the respective terminals, which will be something like this. Here is a positive terminal of the battery, negative terminal of the battery, and then we have, here is one resistance. I will draw here. This is 10 ohm resistance, this is 10 ohm, and voltage is 40 volt. It is plus and minus. Now each resistance is of the 10 ohm. This is 10 every 10. Now here again, and we are interested in this calculation. That is calculation of the resistance between the terminals. That is A and D. That's it. Now here there is no direct series and parallel combination. That's why we will convert this first delta into its equivalent star and delta conversion. This here, this will be the case. Here is resistance R1, this will be the R2, and here this resistance is R3. I will draw its equivalent figure first, because always better to draw the figure and then work out the calculation, means chances of the mistake can be minimized. Here I will do the something connection like this. Here is one resistance which is R1. This is second resistance which is R2, and here will be the third resistance which is R3. Here I will name it as R1, this is as a R2, this will be as R3. Means 1, 2, 3. These three resistances are replaced by inner three resistances, that is star resistances, and remaining part of the circuit will be the same. Means here this is the same, 10 ohm as it is, this 10 ohm as it is. Now here this will be the circuit diagram, and then we can minimize the circuit by using conversion, that is series and parallel combinations. That is by using series and parallel combinations. Yes, this is again it is plus minus, this voltage is 40 volt, this is 10 ohm. Now here we have to calculate the values of the resistances which are R1, R2 and R3. Here the value of the resistance R1, which is equal to, how we are calculating, this is R1. Here it is R1. Multiplication of these two divided by summation of that is delta to star conversion. This here it is 10 into 10 divided by 10 plus 10 plus 10, which is 30. That is, if we are calculating its value, it is coming to be, that is 3.33 ohm is the value of the resistance. We can verify the answer by using calculator also. That is 10 into 10, which is 100 divided by 30. Its value is 3.33 ohm. The similar is the calculation for R2 and R3, because each resistance is of the 10 ohm. 10 means calculation will be the same. Then that's why I will not do the remaining calculation that you can do. That is 3.33 ohm. Now here we know the values of all resistances now. Then we can simplify this figure. Its next figure will be something like this. Here is one resistance, which R1, which is 3.33 ohm. I will keep as it is. Now this R2 is in series with this 10. R2 is in series with the 10. This 10 and this 3.33 means its total value will become, yes, I will modify the figure something in this way. This is 13.33. This is 13.33 ohm is its value. Similarly, this is 10 plus 3.33 means its value is again 13.33. This is again 13.33 ohm is its resistance. Then here we have the 10 ohm resistance. This is 10. Here is the battery, and this is a 40 volt plus minus. Now here, if we are this is 10 ohm again. If we are finding its final figure, it will be something like this. This is 1. Then parallel combination is replaced by another resistance, and here is the 10 ohm resistance, and here is the battery, and we are interested to calculate the current from the battery, which is plus minus, that is 40 volt. This is 10 ohm. This is 3.33 ohm. Now here its parallel combination will be 13.33 into the same value, that is 13.33 into the same value, means its half value will be the resistance, that is 6.66. means here this value is 6.66 ohm, that is R1 into R2 divided by R1 plus R2. If we are doing that calculation, its value we are getting its value as this is 3.3 as it is. Its parallel combination will be this value. This is 40 and it will be the 10 ohm. Means here now we are interested in the current from the battery, this IL. Our current from the battery, which is IL, is equal to total voltage, which is 40, divided by total resistance, which is 10 plus 6.66 plus it is 3.33. You can calculate its value, which is here 40 divided by it is in bracket 10 plus 6.66 plus it is 3.33. I will close the bracket. It is 2 amperes. You see here 2 amperes is the current flowing through the load resistance by using this type of the combinations. Means here in this case important thing is that how to calculate the total resistance between the terminals that we have tried to cover. Now here in the similar way I have another problem which will be again the unique, and in that particular case the calculation of the resistances will become difficult and sometimes it will make the confusion. Now here this will be another problem in which we are interested to calculate the current supplied by the battery for the network shown below. In this particular case again I will use the same technique here. This is A, this will be the B, this is point C, and this is point D. I will make the terminals A, B, C, D. But here I will use a different technique here, because in this case between the point A and C we have zero resistance. Between B and D again we have zero resistance. Zero resistance means these 2 points are at the same point. In place of using this long wire, we can use very short wire, or we can bring these 2 points at a single point. If we are bringing these 2 points at a single point, in that particular case its figure will be something like this. Here what I am doing, I am taking A and C together. This is A and C together. Then I am taking B and D together. Here will be the terminal which is B and D. And if I am connecting the respective terminals, here A and B, between A and B we have 10. This is A and this is B. We have 10 ohm resistance. Here it is 10 ohm resistance. Between B and C we have another 10. This is B and this is C. We have another 10 ohm resistance. Then between C and D we have another 10 ohm resistance. Here is a C. This is D. We have another 10 ohm resistance. And then we have A is connected to the battery. A is connected to the positive terminal of the battery. Here it is something like this. And this D is connected to negative terminal of the battery through one of the resistance. This will be the figure. Here it is of the 10 ohm. Its voltage is, it is 10 volt with plus and minus. Its value is 10 ohm. This is 10 ohm and this is 10 ohm. Now here we can find out this equivalent resistance. Means here this next figure will be something like this. Here is the positive terminal. Here is another resistance and this will be the final figure. It is of the 10 ohm. This is of the 10 volt with positive and negative terminal, and we can find out this RP. This is RP is nothing but, here I will do the calculation. Here this is 1 upon RP final value, which is equal to 1 upon 10 plus it is 1 upon 10 plus it is 1 upon 10, this value. Here in this case, if I am calculating that value, it is 1 divided by 10. This value is coming to be 0.1. Means here it is 0.1 plus this is 0.1 plus it is 0.1. Means here the total value is coming to be 0.3. This total value is, it is 0.3. Now here if I am taking its reciprocal, it is RP is equal to this value 1 upon 0.3. Means here if we are finding this value, it is 1 divided by 0.3, which is nothing but 3.33. This value is 3.33 ohm is this value, that is parallel combination. Then we can calculate its current, that is IL or current from the battery. If I am doing that calculation here, the current taken by the battery, which is IL, is equal to, or current taken from the supply or current in this loop will be total voltage, which is 10 divided by total resistance, that is 10 plus it is 3.33. And if we are doing this calculation, or if we are finding its value it is 10 divided by, it is 13.33, that is 13.33. This is the calculation of the current, which is 0.75 amperes is the current flowing through the load resistance, or current flowing through the supply from the battery. Means these are some tricks and techniques we have to use appropriately for the calculation of the resistance between the terminals A and B. That's all for this particular video. Thank you.